Question number 2 says 2 point charges A and B. There are two charges A and B. Okay, let's draw a rough diagram over here. So let me take this is as our A and this as our B. Having charges Q and minus Q. So let me just write here plus Q and let's keep here minus Q. Okay, Q and minus Q respectively are placed at a certain distance apart and a force acting between them is F. So let's say this separation between them is X or R. You can take anything. Let's take it as R, the separation between A and B, and the force acting between them as per the question is F. This is the force, correct? If 25% of the charge, okay, of A is transferred to B, let me repeat again, if 25% of A is charge of A is transferred to B, then force between the charges becomes how much? Clear? Very simple question. So let's initially write what will be the initial force. So initial force F will be equals to K times charge on A times charge on B. Let me remind you again, we don't take the negative sign because of magnitude, whole divided by R square, correct? So let me rewrite it as our initial force when the charge was not transferred, it was KQ by R square. This is our equation number 1, okay, where K is nothing but 1 by 4 pi epsilon naught if you want to write, okay. Now 25% of charge A of, let me write here, 25% charge of A is transferred to B, okay, 25% of A. Then what will be the charge left in A? Obviously 75% because total is 100 always, right? So what is the charge, new charge on A? So Q dash A, that will become how much? 75% of this charge on A, correct? And that is nothing but how much? QA. QA is Q, right? So 75 upon 100, let's cancel out, it will be 3 by 4. If you divide by 25, 25 3s are, 25 4s are, right? So into Q, correct? Because charge of A is Q. This is our charge on A, new charge on A after the transfer. What is the new charge on B? The new charge on B will be QB. And that will be how much? 25% of A, which is given to B, as well as the charge which was already there on B, correct? Let me repeat again. If 25% is charge is given from A to B, so this is 25% of A plus the B charge, right? Because QB was already there. So what is the charge? 25 by 100, 1 by 4 of QA, which is plus Q. And be careful, charge is a scalar quantity. You can add or subtract. So you have to keep the negative sign, minus Q. Force is a vector quantity, right? So be very careful with that. And charge is a scalar quantity. So for force, vector addition, charge is direct scalar addition. So this will be minus 3Q by 4. This will be the new charge on B. I hope this is clear. So this is A, this is B, new charges. Let's find the new force. So the new force will be F dash, and that will be equals to K, still remains K, nothing changes to the medium. Now what is new charge? QA dash into QB dash whole divided by R square. Nothing, the question is saying nothing about the separation between the two charges, right? So R will still remain R, okay. So let's substitute the new values of charges of A and B. So QA will be nothing but 3 by 4 of Q. Let's keep a bracket to avoid mistakes. And into this is minus 3Q by 4. That's charge on B whole divided by R square. So let's simplify it. 3 3s are 9. So it will be minus 9 upon 16 KQ by Q square by R square. Correct? And what is KQ square by R square from equation 1 over here? The equation 1 says this is nothing but force. F prime will be equals to minus 9 by 16 F. Correct? So we can ignore the negative sign. This is simply the magnitude they are asking. So magnitude of the new force becomes how much? 9 by 16. So that is option A. The correct answer is option